All right, once again, good morning, everyone. And welcome to Saturday Academy. We're going to do a review for the semester final. Once again, a reminder. I am going to share to you that this will be shared with your teachers for next year at the high school, so make sure, stay focused throughout. This is going to be available on YouTube, so make sure for the other study guides that you have at home, if you have any questions, go to the YouTube channel and go through each of the problems. Try and do those first by yourself, and then get help from the video. Everybody with me? All right, so let's get started. Here we go. Number one, we got name the property illustrated in the equation x plus y plus z equals x plus z plus y. First things first. With this, I ask you to write first the order. So you write x, y, z. Then you write whatever's on the other side the same without the operations. You write x, z, and y. The question that we ask is usually, are they in the same order or does the order change? It changes. If it changes, it starts with c. That means it's a commutative. Commutative property. Once you have that down, you need to go back and circle the operation throughout. What was the operation throughout? Addition. So therefore, you're going to write commutative property of addition. If you just write commutative property, I'm going to mark it wrong. Make sure you get the operation correct. Number two, it says, evaluate the expression for the given values of the variables. Whenever you get to any of these that say evaluate, I'm going to ask you to write on the right-hand side or at the top, write PEMDAS. Write your order of operations. Once you do that, let's rewrite the entire expression. But for every variable that you see, you're going to open a parenthesis. So first I'm going to write the numerator. Check this out. I'm going to do 3 parentheses squared. Does everybody see how I open up parentheses for the x? And then minus 2 times, and then I need to open another parenthesis for the y, minus 3, close the big parentheses, squared. That's the numerator. Now let's do the denominator. We got 2 big parentheses, small parentheses for the x, and that's squared, minus 1, close parentheses, minus parentheses, squared. So far, so good? So, at this point, let's do one variable at a time. Let's start with x. So, since you have a pencil, all you're going to do, you circle x, and then you're going to substitute that wherever the x goes. So we start with the numerator. X goes here, so that's a 4. In the denominator, x goes here, so this is a 4. Are we there so far? Okay. Let's do this one. Y. Y is 5. Y goes here. This is 5. And then y is here. This is 5. All right? Now that we substituted, let's evaluate. In order to evaluate, we're going to follow our order of operations. So here we go. It says, parentheses, or the P also serves as grouping symbol. Remember that? So, do we have any grouping symbols? Yes, here. So therefore, before I get started with this, the grouping symbol that I'm looking at, the biggest one is this one. Does everybody see the division bar, the fraction bar? Yes, so I'm going to focus right now just on the numerator, and I'm going to simplify it as much as I can going that way. Okay? Here we go. So I'm focused on the numerator. Do I have a parentheses in the numerator? Yes. So I focus on the inside of the parentheses. What is 5 minus 3? 2. So let's do that. So I'm going to bring everything over. 3 times 4 squared minus 2. And what's left inside the parentheses? 2, and that's a squared. So far, so good? Yes, Mr. Q. Good. All right. Do we have exponents? Yes, right there. So therefore, we get the exponents out of the way. So what is 4 squared? 16, and that's being multiplied by what? 3. And then minus 2. What is 2 squared? 4. So that's times 4. Are we there so far? All right. From there, you circle multiplication and division. Do we have that in the numerator from left to right? Yeah, so what is 3 times 16? 48. And what is negative 2 times 4? Negative 8. So what is 40 minus 8 at the end, because that's addition and subtraction? 40. Are we done simplifying the numerator? Yes. Now we go back and let's do the denominator from the beginning. Now, I know some of you do simplification in between, but there's a greater chance you're going to make a mistake if you do that. So I'm asking you, stay focused on one till you simplify, then go to the denominator and do the same. So let's focus on the denominator again. Here we go. Do we have parentheses on the denominator? Yes. So therefore, let's see. Parentheses, yes. So we're going to focus in here. Inside the parentheses, do we have an exponent? Yes. So what is 4 squared? So we're going to do 2 times 16 minus 1 minus 5 squared. So we're still inside of the parentheses. We haven't left this step. What is 16 minus 1? So this is 2 times 15 minus 5 squared. From there, do we have exponents left? Yes, right here. So this is 25, and we bring the minus and the 2 times 15. So, do we have multiplication and division? We're going from left to right. What is 2 times 15? 30 minus 25. So then, what is addition and subtraction from left to right? This is 5. And what do we have in the numerator? 40. What is 40 divided by 5? 8. It was a long one, right? Okay, good. Let's go to number 3. Once again, key information on this one. Do not forget to write your order of operations. Simplify the numerator first, and then go to the denominator, okay? Here we go, number 3. It says, 3 less than a number is 44. 3 less than a number is 44. What I want you to circle here is the beginning, bless you, where it says 3 less than. 3 less than. Circle that. And we write that after the variable. Make a note for yourself. Right after variable. When do we do that? When it says less than or more than. When it says increase or decrease, you do not do that. Everybody look up, please, to the screen. When it says here increase or decrease, we do not write it after the variable. You just write it as is. Once again, we do not write this after the variable if it says decrease or increase. Tell your neighbor what I just said, please. All right, so let's continue. So with that said, do we know the number? No. If we don't know it, what do we write? X. And then right after, what did we circle? 3 less than. What's less than? Minus 3. What does the word is stand for? Equal 44. Solve that, please. Check your neighbor's work. See if you have something similar to yours. If not, slap them so they can wake up, please. Just kidding, no slapping, no slapping. Plus 3. Be nice. This cancels. We're left with x equals 47. Parents, you got x equals 47? Okay. All right. So with that said, make sure you do not forget on this one, whenever you get to a word problem, if it says less than or more than, you circle it, and that goes after the variable. Okay? Number 4. Here we go. Solve. For this one, make a note for yourself. At the next to it, either to the left or to the right, put an asterisk and write. Check first to see if it's a proportion. Proportion. What does that mean? In parentheses, write fraction equals fraction. So what does that mean? If it's a proportion, that means we're only going to have one fraction. Everybody look up to the screen. Look at this fraction. H plus 1 over 4 equals 2h plus 3 over 5. If we just add those two, then we can just do what? Cross multiply. Remember that? That's what we're going to check first. However, does this one have only a fraction equal to another fraction? No, it has a minus over here and a plus over here. Therefore, step 2, write this down. Multiply times LCD. Multiply times LCD if it's not a proportion. So like that, we can get rid of our fraction. Is that correct? All right. Turn to your neighbor and know what the LCD is on that one, please. Okay. So I heard everybody say 20. Is that correct? So we need to multiply everything. Everything times 20. Everything. So let's do that. 20 times h, what is that? 20h. 20 times h, and this is a negative, so this is 20h. Now pay attention to this when everybody look up. If the 20 was right here by the negative, right here, everybody look up, right there by the negative, what am I going to distribute here? The negative 20 to the h and the negative 20 to the 1. Be careful with these. Everybody see that? So therefore, we're going to have negative 20 and all that over 4. Before I move on, tell your neighbor what I just did, please. Okay. Okay. Yeah, so be careful with these. When it has a little negative here in front of the fraction, make sure you attach the negative to the 20 and you distribute. Okay? All right, so then equal to, what is 20 times 2h? 40h plus 20 times 3, 60, and all that over 5, plus 20 times 1, 20. Let's simplify this. So then 20h, I just bring that down, minus, what is 20h divided by 4? 5h. Negative 20 divided by 4, that's negative 5, equals 40h divided by 5, that's 8h, plus 60 divided by 5, that's 12 plus 20. So now we have an equation without any denominators or fractions. Now we can simplify each side. Let's start with this side. Can I combine like terms? Yes, we can combine these right here. What do we have left? 15h, bring the negative 5 down, equals. Can we combine anything over here? Yes, the 12 and the 20, that becomes plus 32. Bring the 8h down. From there, we need to get all variables to one side. Where do we start? Subtract 8h from each side, the smallest variable. We're left with 7h minus 5 equals 32. From there, we add 5 to each side. We're left with 7h equals 37. What's our last step? Divide by 7, divide by 7. H equals, let me do the division here, see what we get. 37 divided by 7, fits in there 5, that's 35, subtract, that's 2. Decimal fits in there 3, that's 2, sorry. That's 14, subtract, that's 6, bring down another 0. It fits in there 8, that's 56. Subtract, that's 4, 0. And I'll stop right there. So this is 5.28, or yes? Or 5 2/7. Any of those two answers I'll take. So let me just recap on this one before I move over. Make sure you check both things. Number one, if it's a proportion, you cross multiply. If it's not, you multiply times the LCD so you can simplify that. Okay? All right, number 5, here we go. Solve. Let's look at it. Do we have any fractions? No. So here we just distribute to get rid of the grouping symbols. So what is 3 times 5y? 15y. 3 times 2, that's 6, minus y. Equals 2 times y, 2y. 2 times negative 3, that's negative 6. All right, can we combine like terms on this side? What is 15y minus y? 14y, we bring down the plus 6, equals 2y minus 6. What do I do next? Start with the smallest variable, so I subtract 2y, subtract 2y. We're left with 12y plus 6 equals negative 6. Next step, subtract 6, subtract 6. 12y equals negative 12. What's my last step? Divide by 12, divide by 12. Y equals negative 1. Bam. Number 6. What percent of 300 is 60? What percent of 300 is 60? For this one, hold on. Guys, focus please. For this one, whenever you get to the ones with percent, I want you to write your proportion. Is over of equals percent over 100. 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 Is over of equal percent over 100. Is over of equals 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 percent over 100. All right, without reading it, tell your neighbor the proportion. All right, so check this out. What we're going to do, we're going to rewrite it. Here it goes. We rewrite it, but with blanks equals blank. The only one that does not change is the 100, so you need to write that down. The only one that does not change is the 100. So write that down, please. So here we go. First things first, I'm going to circle the word of and the number next to that. So let's see. Of 300, where does that go? On the denominator, so that goes here, 300. Next, I'm going to box the next one is 60. Where does that go? On the numerator. Therefore, what is the only one that they do not give us? The percent, so we're going to write what? X. Now, do we have a proportion? Yes, one fraction equal to another fraction, so here, cross multiply. 300 times x, that's 300x. 60 times 100, that's 6,000. Everybody got it? From there. Okay, so the question was, can we simplify before we cross multiply? Yes, if you see it, go ahead and do that. So here we go, the last step, in order to solve for x, 300 is multiplying, so what do? Divide by 300, divide by 300. 300 over 300 is 1, 1 times x is x. Can we get rid of some zeros? Yes, this one and this one. What is 60 divided by 3? 20. And what is the question? What percent? So this one you need to write percent. Make sure you answer the question. If you just write 20, I'm going to mark you points off. I want to make sure that you understand what you're doing, not just doing numbers, and that's it. All right, here we go. Number 7. It says solve. Whenever we get to these, everybody look up, please. Make a note for yourself. Put a little asterisk. Right. Guys, whenever you get to these that have absolute value, write absolute value equals 2 solutions. What does that mean? That we need to write what? 2 equations. Is that correct? So check this out. So before we write our 2 equations, we need to make sure we leave the absolute value by itself. So what's right outside the absolute value? Negative 55. When it's on the left side, it's multiplying. So let's see. If the negative 55 is multiplying, what is the inverse? Divide by negative 55. Whatever we do to one side, we do to the other side. This becomes 1, so we're left with absolute value x over 2 minus 1 x over 2 x. Give me a second. So from here, I bring down the negative 1, and then absolute value equals negative divided by negative is a positive. That's equal to 2. From there, you're going to make 2 equations, one negative and one positive. So let's do our negative equation. The 2 turns into a negative, and we just write whatever's inside of the absolute value. What's inside? X over 2 minus 1. For our positive, give me a second. For our positive, we write x over 2 minus 1 equals 2. Now, for some of you that you've been doing the same mistake forever in the day, you just found out that you don't change anything inside of the absolute value. Did you notice that? What is the only thing that changes? The whatever is it equal to. If it's a 5, then you change one to negative and the other one is positive. If it's a 2 like this one becomes a negative, the other one becomes a positive. But the rest of it stays the same. Okay? All right, so let's continue. So from here, let's solve each equation. This one, I add 1 to each side. We're left with x over 2 equals negative 1. What is the 2 doing here? Dividing, so we need to multiply times 2. Multiply times 2. This becomes x equals negative 2. Let's solve this one. Plus 1, x divided by 2 equals 3. What's my last step? Times 2 times 2. X equals 6. Does it say to graph? No. We're done. So, if you want to write at the end the solution set, you just write the brackets, negative 2, comma, 6. Brackets. Don't use parentheses. If you use parentheses, that means that you're giving me a point of intersection, and that's not true. Okay? Number 8. Yeah. Write your note again. You should know what to write there. Write your note. What do you see? Absolute value equals 2 solutions. Okay, here we go. So let's get started. We need to simplify the absolute value. Is there anything outside? The 4. So the 4 is a positive 4. Is it multiplying? No, it's not right next. Whenever it's right on the left side, is it on the left side? But it's not right next to the absolute value. In this case, it's not multiplying. In this case, you look at the number. What sign does the number have? A positive. So what is the inverse? Subtract 4 from each side. Subtract 4. We're left with absolute value 2x minus 1 is greater than or equal to 1. Oh. Oh, plus 1. Yeah, I did that on purpose to see if you were paying attention. All right. So here we go. From this point, do we have anything else outside the absolute value? No. Now, this is the one that some of you make mistakes in regards to the symbol. We need to write 1 for our negative and 1 for our positive. So for our negative, check this out. I'm going to write negative 1. But when I write the negative, the inequality symbol, what happens? You flip it. You need to flip it whenever we write the negative number. Yes? So from there, I rewrite whatever's inside, which is 2x plus 1. For my positive 1, I just write everything exactly the same. 2x plus 1 greater than or equal to 1, but without the absolute values. Okay? All right? So from there, if I solve this, I subtract 1, I'm left with 2x less than or equal to negative 2. At the end, I divide by 2, both sides. X is less than or equal to negative 1. This one, subtract 1, 2x greater than or equal to 0. At the end, we divide by 2. X equals 0. I'm sorry, my bad. Is greater than or equal to. I did that on purpose. Everybody got it? Okay, here we go. Next, we have, it says solve. Did we solve it? What do we do next? Graph. So get a line. You have your ruler. If not, make sure you share it with your neighbor. Draw your number line. 0. negative 1. Okay, I'm going to graph the inequality in blue first. Here it goes. It says x is less than negative 1. I need to look at negative 1. Here it is. Do I double it in? Let's see. Does it have an equal sign? Yes, so it is including that point. And then it says x is less than or equal to negative 1. What numbers are less than or equal to negative 1? Everything to the left. All real numbers to the left, okay? All right, we're done with that one. Let's graph the other one in red. 0. Does it include 0, that point? Yes, so you plot your point there. And it says x is greater than or equal to 0. What numbers are greater than or equal to 0? All the ones to the right, and this is an 4. So, yes. Very good, thank you. Your notation, here it goes. You were going to write it. Here it goes. So, for those of you that have difficulty with these, all you have to do is write your bracket, and you write the set of all x such that, what is our first inequality? X is less than or equal to negative 1, and this is the only time you're going to write what? Or x is greater than or equal to 0, and you close your bracket. Okay? Again, for the absolute values, whether it's an equation or an equality, don't forget to make a note. As soon as you see it, you need to write absolute value equal to solutions so that you won't forget. Because many times when we're taking a party and we're working on it, we get so involved with the multiplication and all the stuff of solving that we forget that we need to have two different solutions. Okay? All right, let's continue. Number 9. It says, solve and graph the absolute value inequality. So here we go. Let's look at it. Does it have anything, the absolute value, anything outside the absolute value? Yes, it's being subtracted by 8. So what is the inverse? Add 8 to each side. We're left with absolute value, x minus 2, less than or equal to 5. Do we have anything else outside the absolute value? No. So from that point, we write two inequalities, one for our negative and one for our positive. So for our negative, I write the 5, it becomes negative 5, and when I change it into a negative, what happens to the symbol, the inequality? You flip the inequality symbol. Don't forget that, please. When you get to inequalities, and it's an absolute value for your negative, you always flip it. So let's write x minus 2. So for this positive one, we just rewrite everything the same. X minus 2 less than or equal to 5. Okay? From there, can we solve? Yes. So plus 2, x is greater than or equal to negative 3. And the other one, plus 2, whoops. X is less than or equal to 7. Are we done solving? Yes, we're done solving. Now we need to graph. So get your ruler, get your number line ready. I'm going to graph the one in green first. Let's see, the one in green is negative 3, which is right here. Does it include that point? Yes. So therefore, I plot my point. And it says, x is greater than or equal to negative 3. What numbers are greater than or equal to negative 3? Negative 2, negative 1, or all real numbers to the right of that. Is that correct? So you shade all of this like so. Now I'm going to graph the second one, which is at 7. I start at 7. Does it include 7? Yes, it has an equal sign, so you plot your point there. And it says, x is less than or equal to 7. What numbers are less than or equal to 7? Everything to the left. So do you guys notice that they intersect here? This is an and. Okay, check this out. To make it easier for you guys, if you find it too difficult to write your solution set just by looking at the graph, then let's write it as if it was an OR. So you write the set of all x's such that, what do I write? X greater than or equal to negative 3, and what else? X less than or equal to 7. Everybody see what I did? Okay. Now, for those of us that already know how to write it the other way, everybody look up. I'm going to do that in blue right here, my solution set. I just do it right underneath my graph. The set of all x's such as, and what is the inequality symbol? Less than or equal to, less than or equal to. You can either do it like this, or you can do it like this. Either or, whichever's easier. Because I know some of you forget how to do this one, but we do remember how to do this one. So either or I'll take. Everybody with me? Okay. Yes. All right, let's continue. Number 10. Number 10. It says, if f of x equals negative 2x squared plus x minus 10, what is f of 1? So for these, here we go. So for these, whenever you get to functions, you're going to rewrite this exactly the same, but without the x, you're going to just leave it as an open parentheses. Does everybody see that? Equal negative 2, and instead of x, we open a what? Parentheses, squared, plus, instead of x, what goes there? Parentheses, minus 10. So now, what number are they asking us to check? F of 1, so you just write your 1 here, and everywhere you substituted the x with a parenthesis. Okay? So now, let's do the next step. Let's start simplifying, and with these, notice that this looks like a regular expression, doesn't it? So this one, you need to make sure you follow your order of operations. When simplifying functions that need substituting, make sure you follow your order of operations. So I'm going to write f of 1 equals, let's see. Look at this side. Do we have parentheses? Yes. Could we do anything inside the parentheses? No. Step 2, exponents. Yes. What is 1 squared? 1, and that's going to be multiplied by negative 2 plus 1 minus 10. Everybody see what I did? Next, do we have multiplication and division? We're going from left to right. So let's see, negative 2 times 1, that's negative 2. Anything else? No, just here, positive times a positive is a positive. Bring everything else down. From there, do we have addition and subtraction? We're going from left to right. What is negative 2 plus 1? Negative 1 minus 10, negative 11. Bring everything else down, and we're done. All right, to the right side of that, guys, to the right side of that, I want you to label this next one 10Q. Hey, get it? 10Q? I said to the right of that, I want you to label it 10Q. 10Q. Or right under it if it fits. Here we go. Copy this one down. Focus. F of x equals x squared plus x plus 2. And I want you to evaluate that when it's f of 3. When it's f of 3. Do that one by yourself, please. Let's see if you got this. You should have done this. Anywhere there is an x, you just leave an open parenthesis. You should have done this. F of parentheses, parentheses squared, plus parentheses, plus 2. And instead of that parentheses, we're going to write what? 3. From there, we use our order of operations. Remember that. So it's f of 3 equals, do we have parentheses? Yes, but we can't simplify anymore. Do we have an exponent? Yes. What is 3 squared? 9. Bring everything else down. Plus 3 plus 2. Addition and multiplication and division? No. Addition and subtraction? Yes. So this is f of 3 equals 9 plus 3, that's 12, plus 2, that's 14. Hands if you got that by yourself. Okay? All right, let's go to the next one. Here we go. Number 11. All right, it says, given x 1020, y 8887, it says, give the domain of the relation. So the domain is all x values without repeating. So right here, domain, all x values without repeating. So let's see. So let's start with the smallest number out of here. What is our domain? 0. Okay, 0. What else? 1. What else? 2. Why didn't we write the other 0? Because it says without repeating. So this is my domain. So now let's do the same thing for the range. The range. Range is all what? Y values. And the same without repeating. Without repeating. So let's see. My range is what? 7 and 8. Notice that we didn't write 888. We only wrote it once. Number 3, determine whether the relation is a function. So check this out. Pencils down, eyes up here. Pencils down. Here we go. In order to know if this is a function, I'm going to use the domain. Everybody look up. I'm going to use the domain and write it here. We'll remember these. Okay, this is a mapping diagram. Then I'm going to use my range and write it here. 7, 8. Are we there so far? So now I'm going to map it one at a time. So let's see. 1 to 8. 1 to 8. There it is. 0 to 8. 0 to 8. 2 to 8. 2 to 8. 0 to 7. 0 to 7. Who notices that as soon as we saw, come on in. As soon as we saw that 0 has what? How many outputs? How many outputs? 2. Who notices that 0 has 2 outputs, which is 7 and 8. So therefore, this is not a function. Not a function. Everybody there? Okay? And see if it's a function. Here we go. I'm going to give you another one. This one, you're going to label if it fits to the right of that. Write it to the right. And here it is. Write example 11Q. 11Q. X, Y. Here's the table. negative 1, 0, 2, 4, negative 1, and let's do one more. How about 2? Okay, here we go. For the y values, 1, 2, 3, 4, 1, and 5. Okay, copy that one. I want you to find me the domain, range, and see if it's a function. See if it's a function. Look at this. It says, find the domain, the range, and see if it's a function. So first things first, I'm going to write my domain, which means all x values without repeating. So I'm going to start with the smallest one, which is negative 1. From there, the next one is 0. Do I have a 1? No. Do I have a 2? Yes. The next one up is 4. I already have negative 1 here, and I already have 2 right here, so I don't have to write them again. Hands if you got that. That is correct. Do the range. The range. I'm going to rewrite all these here, but without repeating from lowest to highest. So I'm going to start with 1, 2, 3, 4. 1 repeats, I already have it, and then 5. Hands if you got that. Okay. To check if it's a function, this is where it gets tricky. For some of us, it's a little confusing. But the easiest way of going about it, you get your domain, and you write it here. Negative 1, 0, 2, and 4. Don't rewrite these. Everybody look up. Don't rewrite these. You rewrite your domain. If you rewrite these, you're going to make a mistake. My range, I rewrite it right here. 1, 2, 3, 4, 5. And now we can start mapping. Let's see. And I start here. Negative 1 to 1. Negative 1 to 1. 0 to 2. 0 to 2. 2 to 3. 2 to 3. 4 to 4. 4 to 4. Negative 1 to 1. Negative 1 to 1. It's already there. And 2 to 5. 2 to 5. Who notices that for this one x, there's 2 y's? This is not a function. Oh, 3 and 5. My bad. 3 and 5. Hands if you got that. Not a function. Okay, let's move on. Number 12. Number 12. So look at this one. It says, give the domain and range of the relation. Focus, please. Domain and range of the relation. So I'm going to write domain. I'm going to open bracket and range. And I'm going to open bracket. So check this out. Everybody look up, please. Pens down, pencils down, eyes up here. Focus, please. Here it goes. If I was to get my pencil, and I'm going to do a vertical line test. I'm going to do this. I'm going to scan it from left to right. I'm going to do this. Where does it first touch that graph? At negative 4 of what? What is this variable? X. So therefore my domain, which is x, starts at negative 4. Everybody there? And I'm going to keep scanning it. It goes all the way to what? 4. So then I space this out and I write 4. And for what variable is the domain for? X. Now check this out. Is this a solid point? This one. Is this one a solid point? So then this is less than or equal to, less than or equal to. Because it's a solid point. Nope. It's always like this. Next, the range. Focus, please. Now I'm going to turn my pencil over this way, and I'm going to scan it from the bottom to the top for the y value. Does everybody see how this is the y-axis? So check this out. I'm going to do this. Starting from the bottom. What's the y value right there?
0.
Can you get the door, please? 0. This is 0. Focus, please. All right. And what does it go all the way to? Let's see. It stops at what? 4. And this is for which variable? Y. And once again, does it include these points? And does it include that point? Less than or equal to, less than or equal to. No matter what, it's always going to be less than or equal to. The only time, guys, it doesn't include this, let's say it doesn't have the equal sign, is when it's an open point. Everybody with me? Okay. Want to do another one of these? Okay, number 13. Let's go to number 13. Yes. Say that again? Oh, guys, the question was, how do we know the direction of the arrows? It's always to the what? Left. The arrows are always going to the left. Okay? Yes. Did we answer the other question? Tell whether the relation is a function. No, let's answer that. All right, let's get our pencil. We're going to do a vertical line test. And we're going to scan it from left to right. If it only touches that one spot all the way through, it is a function. Let's see. One spot, one spot, one spot, one spot, one spot, one spot. It is a function. Function. Or just write yes, function. Or yes, it is a function. Okay, let's continue. Here we go. Number 13. Yeah, slope. It says, focus please. Find the slope of the line described by 4x plus 3y equals negative 48. When we get to these, everybody look up please. When we get to these, as soon as you see find the slope of the line and they give you an equation, I want you to write this. Y equals mx plus b. Once again, when you get to these that say find the slope of the line and they give you an equation, I want you to write y equals mx plus b. Why? Because it needs to look like this in order for us to know what is the slope. The slope is always the coefficient of x. It needs to be in this form. Let's look at it. Is it solved for y? No, that means we need to get rid of the x, don't we? So we subtract 4x to each side, subtract 4x. We're left with 3y equals negative 4x minus 48. What's our last step? Divide by 3, divide by 3. 3 over 3 is 1, that's y. Negative 4 divided by 3, that's negative 4 over 3. Bring down the x. Negative divided by a positive, it's a negative. 48 divided by 3, that's 16. But we haven't answered the question, what is the slope? By looking at it, we know that the slope is the coefficient of x. Therefore, you need to write m equals negative 4 over 3. Good question. Everybody look up. Guys, everybody look up. Look at this form right here. Which one is first, the x or the number? The x. Look at this. What came first, the x or the number by itself? So that's why it needs to be in slope-intercept form in order for us to identify the slope. Yes. Yes, let's do another one. Here we go. Copy this one down. Example 13Q. 13Q. Focus, please. Example 13Q. 13Q, they give us the equation 4x plus 6y equals 36, and they want you to find the slope. What is the first thing that we do? We write what? Y equals mx plus b, because it needs to look like that. Now that we know what it needs to look like, do the next steps. Go. We need to get rid of the x. So therefore, subtract 4x, subtract 4x. We're left with 6y equals negative 4x plus 36. Hands if you did that step. Okay, next. Divide by 6, divide by 6. We're left with y equals negative 4 over 6x plus 36. Yes? Okay, just checking. This is 6. 36 divided by 6. So now, what is our slope? M equals negative 4 over 6, which means, in simplified, it's negative 2/3. Simplify it, please. Number 14. All right. This one, it says, without graphing. Without graphing, tell whether this point is on the graph. How do we do that? We substitute the value of x and the value of y into the equation. So what is y? 1. What is x? 5. We bring everything else down. The 2 multiplies 5, the plus, the equals, and the negative 10. Are we there? Next, what is 2 times 5? 10 plus 1 equals negative 10. What is 10 plus 1? Is 11 equal to negative 10? So therefore, not on graph. Yeah, remember yesterday when we did systems of inequalities that we substitute the values to check? That's exactly what we're doing. Let's do another one. Here we go. Guys, focus. Here we go. I want you to check this point. Check the point. Negative 7 plus 4. Negative 7 plus 4. Check and see if that's on this graph. Check and see if that one is on this graph, please, that point. Oh, not plus 4, my bad. 7, 4. Check and see if this one's on this graph. Same equation. Here we go. So we rewrite the equation. This becomes 2 parentheses plus parentheses equals negative 10. And instead of x, what did we write? Negative 7. And instead of y, we wrote 4. This became negative 14 plus 4 equals negative 10. Negative 14 plus 4, that's negative 10. Is negative 10 equal to negative 10? Yes, so therefore this one is yes on the graph. Hands if you got that? Okay. Go to the next one, number 15. After this, we're going to take a break. Here we go. 15. Here it goes. It says, find the x and y intercept. Some of us still get confused with this one. Let me give you an easy way of doing this one. Everybody do this, please. Everybody look up. You're going to do this. You're going to get the x and then equal to negative 24. And then you're going to do another one this way, but now it's going to be the y equal to the same number, negative 24. And then you just solve for each variable. So therefore, let's solve for x. We divide by 3, divide by 3, x equals negative 8. Divide by 4, divide by 4, y equals negative 6. And we're done. So now, check this out. Hold on. From here, guys, focus. To write my coordinate for this one. What is the x value? Negative 8. Therefore, the other one is 0. For the y-intercept, what is my x value? 0, negative 6. That's the answer. Okay, here we go. Let's do another one. Here it goes. You do this one by yourself. Yes, this one is example 15Q. The equation is negative 2x plus 2y equals 16. Find the x and the y intercepts, please. Don't say it out loud. Keep it to yourself. Let everybody think, please. Here we go. Who did this? You wrote negative 2x equals 16, and the other one, 2y equals 16. Divide by negative 2, divide by negative 2, x equals negative 8. Therefore, this is negative 8, 0. Divide by 2, divide by 2, y equals 8. Therefore, this is 0, 8. Hands if you got that. That is correct. All right, we're going to take a little break. That's good. Here we go. Focus, please. Number 16. 16. It says, write the equation in slope-intercept form. Guys, it says, write an equation in slope-intercept form. Whenever you get to these, once again, you need to write the form right away. That form looks like this. Y equals mx plus b. For those of us, again, that still don't know the components for that form, I want you to point to the m. This is the slope. Focus, please. This last part is the y-intercept. So whenever we have an equation that is solved for y and it's written like this, the coefficient of x is the slope. The last number, which is a constant known as the y-intercept. So with that said, it says, write an equation in slope-intercept form of the line through the given points. Graph the equation using the y-intercept and the slope. And and C, it says, write the slope of the line that is perpendicular to the given line. So now check this out. Do they give us an equation? Look at it. Do they give us an equation? No, that means we need parts of this equation. The first thing that we need is what? Slope. We also need a y-intercept. So check this out. We know how to get the slope given 2 points. So when you get 2 points, you're going to label the first one this. Everybody look up. X sub 1, y sub 1. The second point, you're going to label x sub 2, y sub 2. Why? Because we have a formula to get the slope. The formula is m equal y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Is that correct? Okay, that's for the slope. So, let's substitute information. Let's see. What is y sub 2? What was it? 9. So we're going to write 9 minus What is y sub 1? 1. So you write that right there. Let's go with the x's. What is x sub 2? Negative 2. Minus, what is x sub 1? 0. Let's simplify that. Let's see. What is 9 minus 1? 8. Over negative 2 minus 0, that's negative 2. What is 8 divided by negative 2? Negative 4. So now we have our slope. Everybody look up. Do we have a slope? What is it that we don't have? The y. So now check this out. But we do have a slope, and we do have at least one point. We have a point and a slope. Point, slope. Point, slope. Point, slope. Who remembers the point, slope form? Y minus y1 equals m times x minus x1. Okay? This is the form that we need in order to write an equation that ends up looking like this. So now, let's substitute information. What is my slope? What was it? Negative 4. That goes right here. Negative 4. What is x sub 1? 0. What is y sub 1? 1. We bring everything else down. Y minus equal parentheses x minus parentheses. All right, let's distribute that 4. This becomes negative 4x. Negative times a negative is a positive 0 equal to y minus 1. Are we done solving for y? No. To solve for y, what do? Add 1, add 1. We're left with y equals negative 4x plus 1. So now let's see. Part A, it says, write an equation in slope-intercept form. Do we have something that looks like this? Yes, here it is. This one is done. B, graph the equation using the y-intercept and the slope. Do we know how to graph this? Okay, get your ruler, please. And you have your graphing paper, right? Okay. Uh-huh. Yes.
Yes. Yes.
Yes. Okay, here we go. My equation. Okay, what was our equation? Y equals what? Negative 4x plus 1. Let's graph that. We start with our y-intercept. What is our y-intercept? 1 plus 1. So we plot our point there. There it is. Now we use the slope that we found, and we found that the slope was negative 4, but in fraction form is what? Negative 4 over 1. That tells me to go 4 steps down, 1 to the right. 1, 2, 3, 4, 1 to the right. Plot your point. Do it again. 1, 2, 3, 4, 1 to the right. Get your ruler and graph your line all the way through. All right. Did we graph our line? Yes. Using the y-intercept and the slope. So with that said, part B is done. We graphed it. Oh, sorry. We're done with the graph. And part C, it says, write the slope of the line that is perpendicular to this one. Think about it. Don't say it out loud. Focus, please. Write the slope of the line perpendicular. So I want you to underline or circle where it says slope and perpendicular. Think about those two words, slope and perpendicular. The word perpendicular, as soon as you see that, you need to write reciprocal inverse. Remember that? So let's see. What is my slope of the current line? -4. What is the reciprocal inverse of -4? Think about it. +1/4. So for part C, you're going to write m equals 1/4. Let's see all components. The first one. Did we write an equation in slope-intercept form through the points 0, 1, -2, 9? Yes. How did we do that? We got our slope. Here it is. It was -4. Then we use one point in the slope to write our point-slope form. So right there, point-slope form. And at the end, we got a slope-intercept form equation. Slope-intercept form, which is this one. Are we there so far? Okay. Next, did we graph the line using the y-intercept and the slope? Yes. And C, write a slope of the line that is perpendicular. Did we find the slope of this one is -4? Perpendicular is reciprocal inverse, so it's 1/4. Perpendicular means that it's intersecting at 90 degrees. Okay? Everybody got it? Let's do another one. Here we go. Guys, focus. Let me see. Do we have space? On your graph paper, you do have space. Get on your graph paper, write this down. Focus, please. No. Write this down, please. 0.25, either graph, either, and 4/7. 2, 5, and 4/7. I want you to, number one, we need to write an equation in slope-intercept form. Number two, I want you to graph that equation. And number three, I want you to find the slope of a line that is perpendicular to that line that you're going to get. So, just to get you started, our equation at the end needs to look like this. Y equals mx plus b. Is that correct? Next, we're going to label these. What do we label this first point? X sub 1, y sub 1. What do we label the second one? X sub 2, y sub 2. Okay? Right here, what is my formula for the slope of a line? M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Once we have that, what is our point slope form? Y minus y1 equals m times x minus x1. And that's how, once you have that information, you substitute in here, and that's how you're going to write your equation in this form. Okay? Go for it. See if you can do all the parts. You already have an example. I'll be walking around. Try to do this by yourself. So first thing first, you should have substituted in here the values for x sub 1, y sub 1, y sub 2, y sub 1. So check this out. Y sub 2, what is that? 7. Minus, what is y sub 1? 5. Next, x sub 2, what is x sub 2? 4 minus x sub 1 is 2. Therefore, 7 minus 5, that's 2. What is 4 minus 2? That's 2. What is 2 over 2? 1. Now that we have m, if this is m, in this equation, focus please. Instead of m, we're going to substitute 1. Instead of x sub 1 here, we're going to substitute what number? 2. And instead of y sub 1 here, we're going to substitute 5, bring everything else down. The y, the minus, the equals, parentheses, x, the minus, and the parentheses. To solve for y, we need to distribute first this. This becomes x minus 2, bring everything else down. To leave y by itself, I need to add 5 to each side. My equation is y equals x plus 3. Is it in slope-intercept form? Yes. Let's graph this. Here we go. My y-intercept, what is it? 3. My slope, what is it? 1 over 1. That means 1 step up, 1 to the right. 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 We graph our line. There it is. And the last step. What is a line perpendicular, or the slope of the line perpendicular to this one? What was this slope?
1 over 1.
This was 1 over 1. What is my line perpendicular to that? What is the slope?
Negative 1 over 1.
Negative 1 over 1. So therefore, this is part C. Hands if you got all those by yourself. That is correct. Okay, let's move on. Number 17. It says, our favorite systems of equations. It says, solve by substitution. Give me a second. Solve by substitution. Does it say by graphing? Does it say by elimination? No, by substitution. So, for substitution, we need at least one equation solved for one variable. Let me check the first one. Is this one already solved for one variable? No. How about this one? Yes, this one, x is negative 3y plus 12. So for the first equation, instead of writing x, I'm going to write negative 3y plus 12. So check this out. I'm going to rewrite this one over here. I'm going to rewrite it so you can see it. X plus 2y equals 8. But instead of x, I'm going to write what? Negative 3y plus 12. I bring everything else down. The plus 2y equals to 8. From there, can we solve for y? Yes, let's combine like terms. Negative 3y plus 2y, that's negative 1y. I bring everything else down. The 12 and the equal 8. From there, I need to leave y by itself. That means I need to subtract 12 from each side. Subtract 12. We're left with negative 1y equals negative 4. What's my last step? Divide by negative 1. Divide by negative 1. Y equals 4. Am I done? No. I need to solve for x now. Which equation would you like to use, the first or the second? Very good, the second. X equals minus 3y plus 12, bless you. And instead of y, I'm going to substitute 4. Bring everything else down. The x, the equals, the negative 3 is multiplying, plus 12. X equals, what is negative 3 times 4? Negative 12 plus 12. X equals 0. So, the solution to this system is 0, 4. Solution. Up to right there, we are done with that problem. But if you want to make sure that you got it right, what do we need to do with this point? Substitute into both of them, and it makes it true. $18. It says, a collection of 27 nickels and dimes is worth $1.95. How many of each coins are there? First of all, I want you to box the different types of coins, nickels, dimes, and the total of those is 27. Okay? Now with blue, or with a different type of box, I'm going to circle the value. The value is $1.95. That's how much it's worth. They want us to figure out how many of each coin are there in the collection. So here we go. 3 lines down, 1 across. 1, 2, 3. 1 across. I'll do 2 across. Here we go. So let's get started. What kind of coins do we have? We have dimes and nickels. Let's start here with nickels. Nickels, dimes, total. So for the first line, we're going to write the type of coins that we have. What kind of coins do we have? So nickels, instead of nickels, what do we write? N plus, what else goes here? D equals how many total coins? 27 coins. This is how much they are what? Worth, or the cost. I'm going to write worth. How can I write a nickel, what it's worth, Victor? .05N plus, how can I write how much a dime is worth? 0.10D. And what's the total amount? 195. Let's write our two equations. We got N plus D equals 27. The second one is 0.05N plus 0.10D equals 195. So by looking at this, it looks like we can solve this using elimination. So which variable would you like to eliminate? The N. So therefore, if this is a positive 0.5N, this one needs to be what? Negative. So we need to multiply this entire equation times negative 0.05n. Distribute. And let's rewrite it right underneath. Negative 5n, negative 0.05 times n, that's negative 0.05n. Negative 0.05 times c, that's negative 0.05c, equals negative 0.05 times 27. Let me do the multiplication over here. 27 times 0.05, 35. We got 3. That's 13, 0, 0. 13, 5. How many decimal places? 2. So this is 1.35, and it's a negative. From there, we can eliminate. Okay? So here we go. If we eliminate, which variables are going to eliminate? The n. This cancels this. 0.10d minus 0.05, that's 0.05d, equals 1.95 minus 1.35, that's 0.60. And at the end, to solve for d, we need to divide by 0.05, divide by 0.05, d equals, let's see, I'm going to do the division over here. 0.60 divided by 0.05. I move the decimal twice. Same over here. We get rid of it. 5 goes into 60. Let's see, it goes into 6 once. Into 5, that's twice. So d is equal to 12. No. So now, we write our equation. How many times do we have? 12. And how many total coins? 27. So we write our equation over here. N plus D equals 27. And instead of D, we substitute the 12. Bring everything else down. Subtract 12 from each side. N equals 15. So my solution is 15, 12, and let's write a statement. Think about your statement. Don't say it out loud. Think about it. Let's see, it says, a collection of 27 nickels and dimes is worth $1.95. How many of each coin are there? So your statement should read like this. There are 15 nickels and 12 dimes in the collection worth $1.95. 10Q. Okay, here we go. So, let me break down the points for this one. When we get to this problem, part of the problem is going to give you points. Check this out. The setup is going to give you points. The equations is going to give you another set of points. The solution for the first one set of points. The solution for the second one, another set of points. And the last part, this, when you write your ordered pair and your statement, is going to give you points. If you're missing any of those pieces, I'm going to deduct points from your test. So make sure you're focused and you do all the components. Do the next one. Number 19. It says, it took a cyclist 6 hours to travel 48 miles going against the wind. The next day on the return trip, it took the cyclist 3 hours traveling with the wind. What was the speed of the cyclist and the wind?
So we're going to go back and box stuff. First of all, the cyclist took 6 hours, and the travel was what? 48 miles. And I want you to box against the wind. Against the wind. With a different color. It says the next day on the return trip, it took the cyclist 3 hours, and they traveled with the wind. With the wind. And with green, I'm going to underline my question. What was the speed of the cyclist and the wind? So let's draw our table, 3 lines down. 1, 2, 3, 2 across. 1, 2. Okay? Now, who notices that this is a rate problem? So therefore, right away you need to write at the top, rate times time equal distance. So, check this out. I'm going to write, the first information is the very first one that they mentioned. What trip was it? Against the wind. I'm going to write that right here. Against wind. So once again, what do we know about running against the wind? It takes away from your rate. Is that correct? So check this out. So they're asking us for the cyclist and the wind. So how can we write it here? C minus the wind rate. What was the time that it took? 6 hours. And the distance was 48 miles. For the second part, we're going to write with the wind. With wind. Think about it. Don't say it out loud. What should we write here? C plus W. What was the time? 3 hours. And what was the distance? Same distance because it's a return trip. So this is 48. Okay? So let's write our equations down here. With red, I'm going to write the first one. C minus W. And it says times. Is this correct? So I'm going to open parentheses so I can indicate multiplication times 6. And that should equal to 48. Let's write our second equation underneath. C plus W. To indicate multiplication, we open parentheses times 3 equals to 48. Okay? Let's distribute this one. This becomes, let me see, C times 6, that's 6C. 6C. 6 times negative W, that's negative 6W equals to 48. Let's do the same thing for the second. Distribute, this is 3C plus 3W equals 48. I'm going to stop right there really quick. Look at it to make sure you understand up to right there what you did. Look at it, please. Don't just be copying. Think about the steps. Look at each part to make sure you got the parts. Okay? Let's continue. Distribute. We already did. From there, can we eliminate any of the variables? No. However, can we solve one of these variables and use substitution for our last step? Yes. So let's solve this equation down here. Which one do you want to solve for, the C or the W? Okay, let's solve for the C. So therefore we subtract 3W, subtract 3W. We're left with 3C equals negative 3W plus 48. At the end, we divide by 3, divide by 3. C is equal, negative 3 divided by 3, that's negative 1W plus 48 divided by 3, that's 16. So now, do we know what W is? C is.
Yeah.
C is negative W plus 16. So for this one, instead of C, we're going to substitute what? Negative 1W plus 16. All right, let's continue. So I'm going to rewrite this one. I'm going to rewrite it over here. Right there. This becomes 6. I'm going to open up a parentheses for the C. And what goes in there? Negative 1W plus 16. Let me rewrite that again. Negative 1W plus 16. Close parentheses. What's next? Minus 6W equals 48. So pretty much I just rewrote this one over here, but instead of C, I substitute negative W plus 16. Let's distribute. What do we get? Let's see. 6 times negative W, that's negative 6W. 6 times 16, that's 96. We bring down the negative 6W equals to 48. Can we combine like terms? Yes. Negative 6 and negative 6 becomes negative 12W. Bring down the plus 96 equal to 48. Next step. Minus 96 minus 96. Negative 12W equals negative 48. And what's our last step? Divide by negative 12. Divide by negative 12. W equals 4. So let's see. What does the W stand for again? The wind speed. So therefore, the wind speed is 4 what? Miles per hour. Just MPH. So we got that. So let's see. Which equation do you want to use? The top one or the second one? Okay, let's use the top one. 6C minus 6W equals 48. Now we're going to substitute for the W in here. This becomes 6C minus 6, and instead of W, what do we write? 4 equals to 48. Let's solve that. Negative 6 times 4, that's negative 24. Bring down the 6C equals 48. Plus 24 plus 24. 6C equals 72. And the last step, divide by 6, divide by 6. C equals to 12 miles per hour. So let's look at the question so we can answer it correctly with our statement. Let's see. The question was, what was the speed of the cyclist and the wind? So think about your statement. Don't say it out loud. Okay, so then I write my ordered pair. This is 12:4, and my statement. The speed of the cyclist is 12 miles per hour, and the speed of the wind is 4 miles per hour. Thank you. On your graph paper, I want you to copy this next one. Let's do another one of these. Here it goes. You don't have room? Okay. On your graph paper. There it goes. Focus. Okay, here we go. So for this next one, let's say that the cyclist, did the trip in 4 hours, and it was a 30-mile trip, and he was going with tailwind. And then the next trip he did against the wind. It took 6 hours on the return trip. What's the speed of the cyclist and wind? If the cyclist is going one way with a tailwind, 30 miles, if he returns, what's the distance? Same thing, 30 miles. Set that one up. See how you set it up? You already have an example. Solve for that. Go. So for this one, first things first, I need to box and underline stuff. The cyclist, it took 4 hours, 30-mile trip with a tailwind. Against the wind, it took 6 hours, and it took the same distance. So I make my table. 1, 2, 3, 2 across. It's a rate problem, so I write rate times time equals distance. All right, so the first part, I'm going to write the tailwind. When it's a tailwind, that means that the wind is helping us by hitting us in our back, and it increases our rate, our speed. It increases our speed. The tailwind increases our speed. What two things are they talking about? The cyclist and the wind. So this is C plus W. What was the tailwind time? It was 4 hours. And what was the distance? 30 miles. The second setup is against the wind. Against the wind. If it's against, what happens when we go against the wind? It takes away from our rate. And once again, it's talking about the cyclist and the wind. How long did it take? 6 hours. Distance, 30 miles. Now that we have that, we need to write our equations. I'm going to write them right underneath. C plus W times 4 is equal to 30. The second one, C minus W times 6 equals 30. I distribute. This becomes 4C plus 4W equals 30. This one becomes 6C minus 6W equals 30. Now check this out. For some of us, it's really hard for us to solve with substitution because we need a couple of steps. Some of us decided to do it by elimination. Which one already has opposite signs, the C or the W? The W. Look at the W. Isn't this a negative? This is a positive? Yes? So, what number can I multiply this one and this one so that we have a common number for both? 12? What do you guys think? 12. Is 12 is our least common multiple? Yeah. 3 times 4, that's 12, and negative 6 times 2, that's negative 12. Does everybody see that? Okay? Check this out. So, if I multiply this one times 3, is this going to be a positive 12? What number do I need to multiply this one to make this a negative 12? 2. So let's rewrite this. This is 12C plus 12W equals 90. And I'm going to distribute this one. This is 12C minus 12W equals 60. Now can we eliminate? Yes. Is this method faster than the substitution? Okay, so you can do it like that. Here we go. These cancel. We're left with 24C equals 90 plus 60. That's 150. Is that correct? And then at the end, to solve for C, we divide by 24, divide by 24. Let's see. 150 divided by 24. 24 fits in there. 6. Let's see. 6 times 4, that's 24. We got 2. 12 plus 2, that's 4. That's 14. Subtract, that's 6. And then I add a decimal, 0. 24 fits in there twice. That's 48. Subtract, that's 12. Add a 0. 24 fits in there 5 times. That's 120. Subtract. So the cyclist speed is 6.25 what? Miles per hour. If that's the cyclist speed, which equation do you want to use to solve for the W? The first one. So I'm going to rewrite this one. 12C plus 12W equals 90. Instead of C, I'm going to substitute in there 6.25 times 12 plus 12W equals 90. So let's see. 12 times 6.25 times 6.25. This is 0, 6, 4, 2, 12, 13, 0, 12, 6, 1, 2 decimal places. This is 16.20 plus 2W equals 90. Continue solving for W. That means we subtract 16.20, subtract 16.20. 2W equals 73.80. At the end, we divide by, did I make a mistake? What is this? 12, oh, this is 12W, I'm sorry. At the end, we divide by 12, divide by 12. W equals, let me see, 73.80 divided by 12 fits in there 6. That's 72. Subtract, that's 1. Add an 8. Fits in there once. Subtract, that's 6. 0, that's 5. The wind speed is 6.15 miles per hour. Did I make a mistake? Where? .25. Oh, my bad. 25. Right there?
Whoa.
Yes.
I did substitution.
Yeah, you can do substitution.
Because I did it. I got.
What do we get? Let me see. Let me double check my work. Here we go. So, focus, please. Elimination, 24. This became 150. Divide by 24. That gives us 6.25. 6.25, which is C. We substitute into that. That becomes 76.2. 12W, I bring that down. That is, let's see, 6. Oh, I think I made a mistake here on the multiplication. Sorry, I made a mistake right here. Let me change this. Sorry.
And then it turns out big.
Okay, I'm going to do this one again. 6.25 times 12. 10, 5, 12, 5, 2, 6. There it is. 0, 0, 5, 7. 2 decimal places. That's 75. That was a mistake right there. Plus 12W equals 90. Subtract 75. 12W equals 15. Divide by 12. W equals 15 divided by 12. Fits in there once. Subtract, that's 3. Add a 0. Fits in there twice. That's 24. 6. 5. This is 1.25 miles per hour. So, our solution, the cyclist speed is 6.25 miles per hour. The wind speed is 1.25 miles per hour. Number 20. Here we go. It says, a paint mixer wants to mix paint that is 15% gloss with paint that is 30% gloss to make 6 gallons of paint that is 25% gloss. Okay, how many gallons of each paint should the paint mixer mix together? I'm going to go back, circle stuff. So first of all, we have 15 gloss, 30% gloss, 25% gloss. And then what kind of items are they talking about? They're talking about paint throughout. 6 gallons of paint. Paint. So the question is, how many gallons of each paint should the painter mix together? Let's write our table. 1, 2, 3. 1 across. 2 across. So this is a mixture problem. How many mixtures do they have? Let's see. Paint is 15% gloss with a paint that is 30% gloss. How many mixes? Let's see. The paint mixer wants to mix paint that is 15% gloss with 30% gloss. How many mixes?
2.
2. So this is first, second, and total. What is our first mix? 15%. Our second, 30%. Our total,
5%.
25%. So here, we're going to write gloss. How can we write 15% in decimal?
0.15.
0.15, and this is X plus 0.30 Y equals 0.25, but this one we need to multiply times what? 6. So let's see. 0.25 times 6, that's 30. We got 3 12, that's 15. 2 decimal places, so it's 1.5. Remember, when we write our equation, at the end we just equal to 1.5. The second one, what are they talking about? What item? Paint. So they mix one type of paint, which is X, plus the second amount of paint, which is Y, and we get a total of how many gallons? 6. Okay, let's write our equations. We got 0.15x plus 0.30y equals 1.50. And our second equation is x plus y equals 6. Taylor, and we multiply times negative 0.15. This becomes negative 0.15x minus 0.15y equals negative, let's see, 0.15 times 6. 0, 3, that's 9, 2 decimal places, so this is 0.90. And it's a negative, right? Okay, let's eliminate. This cancels this. We're left with positive 0.15y equals 15 minus 9, what is that? 0.60. What's the last step? Divide by 0.15, divide by 0.15. Y is equal to, let me see, 0.60 divided by 0.15, move the decimal over twice, so we get rid of it for both. So this is for what? Gallons, or gallons. So if we already solved for y, what do we need to solve for? X. So we rewrite our equation over here, x plus y equals 6. Y we said is 4. Bring everything else down. X plus 4 equals 6. Subtract 4, subtract 4. X equals 2 gallons. So our solution is 2, 4. Think about your statement. A paint mixer wants to mix paint, but the question is how many gallons of each paint should the paint mixer mix? So think about your statement. Don't say it out loud. Write it down, please. Write down your statement. It should read something like this. The paint mixer uses 2 gallons of the 15% gloss or paint, either way, and 4 gallons, let's see, of the 30% gloss. 10Q. Hands if this one went a little bit better. Yes? Okay. Move on to the next one, 21. 21. Okay, it says, graph the system of inequalities. Graph the system of inequalities. Get that graph paper. Oh, I already included a graph paper. Let me get mine. Sorry. No, you have yours right there. That's fine. I'm going to use a different one. Here we go. Let's graph it. Give me a second. Sorry. All right, here we go. Let's graph this. I'm going to rewrite the system because it's not letting me just overlay it. Here we go. So for this one, no. Read me the system, please. X equals what? Or X?
Is greater than negative 2. Y is less than or greater than, less than or equal to 2x.
Okay, here we go. Let's graph this one first. Here we go. We start at positive 7. Where's that at? Right here. Okay, there it is, positive 7. What is my slope? 2 up, 1 to the right. 2 up, 1 to the right. Face your point. 2 up, 1 to the right. 2 up, 1 to the right. 2 up, 1 to the right. Before you sketch your line, everybody look up. Make sure this one has an equal sign in order to be a solid line. If it does have it, you sketch your solid line. All the way through, this is a solid line if it has the equal sign. Okay, let's see. Which way are we going to shade? Let's see. I'm going to use this information. Everybody look up. This is where some of you forget to use this information. It says y is less than or equal to. So I'm going to write that here. Y is less than or equal to. And what is the last information that I need? 7. So I use this part and I use this part. So now let me read this. Y is less than or equal to 7. Where's 7 of y? Right here. What numbers are less than or equal to 7? Everything down here. And in what region are all these numbers found? Down here. So you shade everything down here. Huh? Okay. All right. Okay, here we go. Second part, let's go. Second equation. Everybody look up, please. So we got our region for the first part, yes?
Yes.
All right, let's scratch this one. Everybody look up. Notice that this one's a little bit different. It says x is greater than -2. First of all, let's go to -2 of x. Where's -2 of x? X is right here. -2 is right here. Place your point there. All right? So now, does it have a y? Look at that equation. Does it have a y? No, it doesn't. And look at the inequality symbol. Does it have an equal sign? No. So we need to sketch a dashed line or dotted line going through that point, which means it's going to be a what? A vertical line crossing through that point. So it needs to look something like that. Yeah, it has to be dashed, right?
Yeah.
Okay. Straight up and down. Sure. Okay, here we go. Everybody got it up to right there? Okay, so check this out. Let's look at the inequality. It says x is greater than -2. Think about it. Here's x, -2. Think about it. What numbers are greater than -2? Think about it. Don't say it out loud. Who said -1, 0, 1, or all real numbers greater than -1? Yes? So it includes all these numbers over here. So which region are we going to shade? The one over here or the one over here? This one. So make sure you do your dashed lines going across that way. Or your lines, your shaded region. Okay. Does everybody see where the regions overlap?
Yeah.
Yes. Let me highlight it so you can see it. Everybody look up. Look up. Look up. Do you see these two regions overlapping here up to right here? And all of this. Who sees that? Hands if you see that. Okay? So I want you to label that section. What are we going to label it? Solution set. Solution set. What does that mean? Think about it. What does that mean? Think about it. Think about it. Tell your neighbor what that means. What does a solution set mean?
Any point in that area will make both the inequality.
Okay. So, as your neighbor said, any of these points will make both inequalities true. Is that correct? Yes. All right. So, with that said, we're done with that. Let's go to number, sorry. What was the next one? $22. There we go. Polynomials. Yeah. Here we go. Focus, please. It says, simplify. Let's look at this one. Does this one have an exponent outside of the parentheses? No. So this one, we're just going to rewrite it right here. 4x cubed y to the 7th times. Look at this one. Does this one have an exponent? Yes, it's a 2. And we need to distribute that exponent into each of the numbers inside. What is the exponent on the 7? 1. So that becomes 7 to the 2nd, x to the what? 4, y to the 6. Are we there so far?
Yes.
Okay. Let's start with the numbers. Here it goes. 4 times 7 squared. What is 7 squared? 49. 49 times 4, let's see. 4 times 40 is 160. 4 times 9, that's 36. What's 160 plus 36? 196. So we're done with our numbers. If you don't see it, make sure you do your long multiplication on the side. Bless you. Okay? Let's focus on the numbers. Let's look at the variables. Yes. Why did I multiply what? 4 times 4? Because it doesn't have an exponent outside of the parentheses. Okay, here we go. Focus, please. We're done with the numbers. Let's focus on the variables. What is x cubed times x to the 4th? X to the 7th. Remember, when we're multiplying, we add the exponents. What is 3 plus 4? 7. Go on the next one. Y to the 7th times y to the 6th becomes y to the 13. And we're done. Is it coming back? Remember these? Okay, let's go to number 23. 23. Here we go. Here we go. Multiply. It says, multiply. Notice that these don't have an exponent outside of the parentheses. Are we there? So therefore, we need to multiply this times each of these terms. Everybody with me? So let's multiply this times this first one. Start with the numbers. What is 5 times 2? What is s squared times s to the first?
S cubed.
S to the third. Do we have a t inside right here in the first term? No, so we just write t cubed. Are we there? Next. Same one, now times the second term. 5 times 3, times negative 3. Negative 15. Do we have an s right here? No, so we just write s squared. What is t cubed times t squared? T to the 5th. And we're done. Pens down, pencils down, eyes up here. Okay, this is the common mistake that we do. Here it goes. You think that because there's an S and a T, sometimes you guys subtract these two and you continue going. The only time that we can do that is when they have the exact same exponents. Do they have the exact same exponents? No, so we're done. Up to right there, it's simplified. Just write simplified. Simplified. Oh, simplified. Sorry. We got it? Number 23 plus 1. 24. Let's see. Here we go. Step 1, let's rewrite this. 5x plus 9 times 5x plus 9. Focus, please. Okay, here we go. Let's do one step at a time. I'm going to circle the 5x, and I'm going to multiply times each of these terms. What is 5 times 5? 25. What is x times x? X to the second. I'm done with this first term. Now I go to the second. What is 5 times 9? 45, and we carry the x. Are we there so far?
Yes.
Next, the second term times these two again. Let's see, 9 times 5x, 45x. 9 times 9, that is what? 81. Okay, let's see. Can we combine like terms? Yes. 45 plus 45x, 90x. Bring everything else down. 25x squared plus 81, and we're done. Yes?
Yeah.
Number 25. 25. Look at that one. Multiply that one by yourself, see what you get, and I'll be walking around. Go. We multiply 2x times x, that's 2x squared. Multiply 2x times negative 6, that's negative 12x. Then we multiply 5 times x, that's plus 5x. Multiply 5 times negative 6, that's negative 30. Combine like terms. What's negative 12x plus 5x? That's negative 7x. Bring everything else down. So we got 2x squared minus 30. Hands if you got that. Okay? Let's go to number 26. Guys, focus. We're almost done. Last one. Here we go. 26. Focus, please. Here we go. 26. For these, this is saying, what is the fifth root of 32? Which means, what number times itself how many times? 5 times. 1, 2, 3, 4, 5 gives us 32. So let's think about it. Is it 1? Is it 2? Let's see. 2 times 2, that's 4, times 4, that's 16, times 2, that's 32. So therefore, this is 2. For the variables, all we have to do is divide the exponent by the index. What's 20 divided by 5?
4.
So this is x to the 4th. And this is 50 divided by 5, that's 10. Hands if you got that by yourself. Okay, for homework, pay attention. Homework. This was study guide number 2. So you already have study guide number 2. Pay attention to what I'm about to say. I want you to go home tomorrow or Monday. You're going to go over study guide number 2 again by yourself. It's blank at home. Go over it one by one. Check your answers with the work that we did, see how you do. That's going to be like a little test for yourself. Everybody with me?
Yeah.
And that's how you're going to be able to check it. If not, focus please. This video I'm going to upload on YouTube so you can have it also as a resource. Everybody got it?
Yeah.
Have a good one, guys. Enjoy your weekend. See you guys on Tuesday.